One and all. Today, my brilliant student by name Guru Sai Guru Charan from third year data science, who is fantastic at technically whether it's Python, generative AI, transformers. He'll be explaining a case study on multilingual transformers. So I request Sai to start. Sai, you can start.
Yes, coming to the point, myself Sai Charan, I'm third year data science student, and today I'm explaining about my case study about transformers. The priority is mainly focused on the multilingual support. It is one of the use cases of transformers. Coming to the transformers, it is basically a type of neural network architecture introduced by the Vaswan in 2017. It is primarily designed for the NLP tasks. Their evolution like field due to the ability of a model on long range dependencies using an attention mechanism, like which allows them to weigh importance of each word in a sequence. Unlike like traditional RNNs like recurrent neural networks, transformers process this sequential simultaneously, enabling the faster training and leading the state of art in results like text generation and image generations, like so many, and language translation. In this, we are talking about the language translation. And coming to the model overview, I used that GPA AI for Bharat model. Like it is all open model for the Hugging Face. This model was used by the current central government of India, and this was basically designed for the Indic languages. It is robust for the even officially by the government of India for various traditional tasks and translation tasks. This model can handle for the complex translation, like we can support long sentences or summary type also across in multiple Indian languages. But in this we have to explain only about two languages. If we can we can extend up to vast number of languages. And coming to the deep learning techniques of this model relies on a deep learning techniques, particularly on transformers, and revolutionized natural language processing by allowing the models to capture long range of dependencies in text through the mechanism called self-attention. And this enables the model understand the nuances of language better and generate more accurate translations than other transformers. And coming to the architecture of this model, it uses an encoder and decoder architecture. In this structure, an encoder takes an input text, for example, sentence like a Hindi or Telugu or English. It takes an input and converts into the series of high-dimensional vectors. And the decoder interprets these vectors to produce the translated sentence into the target language. And coming to what the task of the encoder and decoder is, encoder captures the essence of structure of the input into the one language, and decoder generates the accurate translation based on the understanding of other language. And this it is a pre-trained model benefits, like we are using a pre-trained model. It was a very good model. Coming to using pre-trained model of Indica Trans 2, it is extremely beneficial. It was being trained on a massive data sets of a multilingual and vast number of components and vast number of sentences and vast accurately. It was a very good data set. Coming to the complex language patterns, it can understand easily, and slang, idiomatic expressions, and even cultural context to different of Indic languages. And coming to the code part, I'm talking about the documentation. Like first, basic documentation was this. The model was completely based on a project overview. It is a multilingual transform model. And coming to the document, this was the documentation, like about the project and how the code works of each code part. It was divided into three code parts. What's the purpose of each code and divided saying about the abstract. You can check out. I will mention the link in this description. um, Coming to the explanation part, this part was I said about previously at the starting of video. Majorly focus on the learning purpose only, and focus of getting decent results for rather than building an alternative for existing multilingual models. Like coming to it was implementing by but style tokenizer. We can we can learn about but in this project also. And the model understands of language and translate based on the pretending language. I use it only like token based inputs. Coming to this point, I use it only English, Telugu, and Hindi. And, we complete to all sentences. I use a text tag, and these were the example inputs and outputs. This was about the, and coming to the major core part. At starting of the web, I install the necessary modules like NumPy and Pandas, what is basic for the training of dataset and doing the data analysis process. And coming to the process, and I install the PyTorch libraries for building of training models and loading of dataset and tokenizers to doing the inputs and for the supporting of encoder decoder architecture. And for the file handling, I use it for the bar and utilities functions like scalar models and random. And coming to loading the required modules and coming to that part and setting the environment for these tokenizers. The next part is load the English and Hindi dataset from the for the code. And coming to this code, you can understand converting the training and validation and test data in pandas data frame. Like you can know that basic conversion of dataset into the training and testing dataset, and adding language to the identifier for Hindi. Like I am adding the Hindi language and Telugu language and English language for the training. Like this was the Hindi language part, and coming to the this one is the Telugu data set. So this was the Telugu part, and I am concentrate on Hindi and Telugu training only for the validation. It was a long length video, so I am majorly focusing on two videos. And after the processing of running this code, it was processed like this. You can see the output. And coming to that, I divided the dataset into two parts like train df. It was the train df. And coming to the second part, display the length of the training. Like I am displaying the length of training. It was a basic data analysis process. Coming to that, continuing the training validation process, like shuffling the dataset of better and tokenizing, understanding and dividing the null values and initializing the WordPress tokenizer. And coming to this part, defining a special tokens for the training localizer. Like if I am giving the input in a tokens, so that's why I'm defining the special tokens in a training tokenizer and enabling the padding and transaction for sequences. Like this was the that code but tokenizer. I start at the end at the starting of the video I said that we use the but tokenizers. It was the very useful for these transformers. And coming to that, I am using a save that train tokenizer for a file. At the above part we are giving the tokenizer. Of that tokenizer I am saving into the file. Of that file we are translating to the encoding. We are coming to the encoding part. An example of encoding and decoding is a Hindi sentences. Coming to this part is giving the Hindi sentences to encoding and convert to the English. Or coming to the second part, example of decoding a Telugu sentence. When I'm giving a Telugu sentence or English sentence, it is decoding that sentence and giving the input in the Telugu. This was the examples of this token. Yes, you can see that. And coming to this was the printing of tokens IDs for the special tokens. Like if I am printing for the special IDs for the separate tokens. It was not a necessary one. You can skip it for that part only. And coming to this code part, dataset class is to handling the preprocessing. It is the complete preprocessing of dataset. And coming to this one, if the length and int function are the default functions, and first I am doing tokenize the English and target language detail sentences. And coming to this, shift target tokens for the teacher course. And next one is I'm using the PyTorch for the models. And I can use this at this stage, converting the PyTorch tensors. And the second part, and you can see the below, I am replacing the tokens with a 100 to 100 losses of the calculations. You can understand from this code. And coming to second part, I am creating a training and validation datasets for separate ones. And for this, I am separating the datasets into two parts for the training and validation and printing the tokenized sentences in a below part for right shifting ones. You can see the output of English tokens and the language tokens and right shifter language tokens. And coming to the second part also, I am again importing the torch functions by requirement of the transformers. It is more Python. You can ask that various modules by, instead of PyTorch, but it is the efficient model for the transformers, and we can do the play with it, and it is easy to work with it. And coming to this transformer, then we can define the RMS form layer for the normalization. And coming to this part, you can understand the code. It was a basic default code for the init function like self functions and giving that self scale functions. Coming to this optional learnable bits transform based parameter this wise. And coming to below one, it was normalized the token part and full form that the calculation in that encoder decoder part. And coming to below one, it is the partial RMS calculation. It was completely on a model based architecture this code. And like in encoder decoder we convert the inputs into the decoder. So in between we use the model. So the model the working of this model is we can written in this code like converting parameters and etc. Partial, like in this you can see that code else below of else partial RMS calculation, and that beside of the code size of the partial normalization, and below and coming to the L2 normal and partial support. And this was the basic code of returning scaled and optimally biased normalized output. And coming to the second one, same, this was also same about that, but it was a special parameters coming to that. Like model, this was basically focused on the model dimensions and the attention number of attention layer and checking the usability. I mentioned all these points in the code in the comment section. Like you can see the comments, comment of the code. You can easily understand by the seeing comments of. I write the each line comment for the explanation. Coming to this part, you can ensure that mask of the same data type or type of this device, and getting the dimensions of the attention scores, and applying the softmax to get the attention weights. I am applying for this softmax function and computing the output of the writing attention weights. And coming to the below words and first linear layer and the dropout layers, we are dividing the layers for layers type. You can know that from the deep learning and CLU activation and the second layer, second linear layer. And coming to the second part, forward pass through the feed forward network. And yeah, I'm forwarding the feed forward. And coming to the encoder block, this was the encoder block, and it is the multi-head attention layer and layer normalization 1 and layer normalization 2. It was the function which is the feed to the encoder. And coming to the forward, it was apply first layer of the normalization, this one. And coming to the second part, and apply multi-head with the residual connection. And second part, it was apply the second layer normalization. Again, feed forward to the network is residual. Like we can continue this process for the 8 sentences. And coming to decoder block, same. It was self attention layer and core attention layer. And layer normalization 1, 2, 3. And same feed forward layer, like applying first layer normalization and converting to the self attention with the way, and applying second layer and converting self attention to the encoder for the encoder output, and applying third layer normalization feed for the residual connection again same. And coming to the embeddings, you know that for the encoder, for the encoding and decoding connection, and coming to the embeddings, it is the maximum length of input sentence. So like what is the maximum length of input sentence, I am knowing that. And coming to the class embeddings for the tokens, like basically I said that in my I can running this code taking input in a form of tokens. Like coming to this, and positional embeddings for the sequence positions. And below part was like look up the embeddings and creating the positional indices, and add positional embeddings to the token embeddings. Like you basically understand that sequential transforms. I mentioned that at the starting of the video, explaining about the transformers. I said that it was basically sequence transformer. We can easily transform the sequence to sequence for language generation or image generations or text summarizations, like many use cases. And this was the encoder decoder blocks, like converting the sequence to sequence transformers. And coming to this part, it was the basic code. It was a default code initializing weights to the linear embedding layers, like initializing each weight to the embedding layers of the encoder decoder architectures, and coming to the each creating a source task for the ignoring padding tokens. And second part, creating a source mask and embedding the source input and embedding the target input. It was giving that first line giving that the source input embed. The second giving that I am giving the mask like a target input for the embed. And coming to the second part, I'm passing this encoder and decoder blocks to the output format. And encoder blocks forward pass, and second line is decoder forward pass. And coming to this part, and final layer normalization. After that, all passes from the encoder and decoder parts, and final layer normalization comes. The labels is not in value. Like I'm coming to this part, like compute loss if the labels are not provided or provided, and getting length of the and then coming to the generation, and when coming to the generate the sequence of the input source, like initializing the target with the beginning sequence token. And I said that initialize the target with the beginning of the sequence token. Again, I think you can understand. Move the target to the and same device as the source. Like I am using this laptop as a source and moving the target to the same source, like not was another source to any, right? And getting the output from the model, and I'm passing this output input sentence to the architecture, and this model is convert this sentence and pass to us, and getting the output from the model and applying the temperature scaling and converting the logic predictables, and selecting the tokens, like which language I have to transform or the highest probability. It selects the highest probability. Like if we say hi, and it was check the all tokens related to hi, like it was in Hindi, in Telugu, Namaskaram, or etc. It was select all the tokens. It will select the which token which has the highest probability, and select that one and display it as the output. And this was the that part. And stop, and at the where stop means it the stop if the end of the sequences token is checked, like all the part is completed, it will stop the sequences, return the generated sequence. And coming to this part, it was configuration settings for the sequence transformer. So like basic configuration settings, you can type it in ChatGPT or anything. It was basic settings, you can change it in based on your project. And initializing the sequence to sequence transformer model and move it into the GPU faster than computation. Like you may know that like for CPU it was like taking so long time than the GPU. So that's why I use it at converting to the GPU for the faster computation and faster optimizations. And calculating and print the total number of trained parameter in the model. Like you can see that number.
Yes.
And coming to the second part, the above part was a whole, in my opinion, it was about the first part. Coming to second part, displaying the model architecture, and this was the model architecture. And you can see and understand it was a sequence to sequence transform and embeddings and encoder decoder architecture. Like at the starting of the video I said that you can see that model architecture and output will be treated in a scalable way. And coming to the second part, creating the data encoder instances for a training and validation datasets. Like you can even know that I'm creating a data encoder for the each. Like I divided the training and validation datasets for the two parts. I'm creating for the data encoder instances for two of them. Like you can create like a train or test dataset in your opinions. You can also create for the data encoder for the each ones data loader. So and printing that number of batches in the training and validation parameters. And like preparing a test samples for prediction of each containing source text and target text. Like I'm preparing a test samples, like you can giving input or training. I divide the dataset into the three parts like validations and tests. Like you may know that setting the number of training epochs and initializing the lists of start and each speech further. I set the epochs as a 5 and try losses list of store of average training losses per speech. I'm storing that what's the losses of training and what's the losses of valid test dataset, and initializing the best validation loss for a very high value, that one parameter initializing that. And coming to the below part, I am tracking the all losses and learning refers to the later analysis. For the later analysis, I mentioned that I am referring and storing that all training losses for the later analysis, and listing of store that all training losses in these two variables or in a list format. List is to store a learning rates in a during training. Like I am storing the learning rates for the each in a training part, and for I am using for it in a later analysis part. Like you may see that in below. And initialize is that in a Adam optimizer with a learning rate of LEA for the model parameters. And second one is the setting of the conscious learning rate. And below one is the initialize a gradient scalar for a mixed precision training and improving the performance. And coming to the this part, it was starting the training loop with the first part. This part only the training loop was started. The first part it is taken the input and setting the model to the training mode and initializing total training loss for this epoch. I set it for the starting epoch is 5 and it initializing the total training loss for this epoch and progress this for the training iteration and iterate over the batches from the training data looker. And you can see that each code line, like about coming to this part, scale to losses for the each background pass, and this part step the optimizer to update model parameters, etc. And coming to bottom of this code, I'm calculating the average training loss about for this epoch. I said that I am calculate for the training losses for further analysis, so I am calculating the training losses. Coming to the torch, you can queue down and model evaluation, setting the model to the evaluation mode for the validation. I am evaluating the model. Coming to this part, calculating the average validation for this epoch. I am calculating average validation for every epoch, like you may know that. And record validation loss and printing the training and validation losses for the current epoch. I said that in the previous lab I will store the validation and current training losses for the every epoch for the later analysis, checking if the current validation loss is best to best so far. I'm checking for that, like coming to the previous validation and best validation, and printing that about that current printing the current epoch model. And this was that code part. And coming to the second part, clearing the memory to avoid the memory errors, like storing of all this memory we can issue that memory issues or anything issues related to memory. So that's why I'm clearing the memory to avoid that memory errors or etc. further during validation or testing purposes. And you can see this outputs for the tokens or training losses. For this I'm storing everyone. In this epoch 0, training loss was the 5.49 and valid loss was 5.32, and saving this as the best model and saving this epoch checkpoint. Of considering the all epochs, the model is fitted that fixed that the epoch loss training loss is 5.4 and valid loss is 5.1. This was said that saving this is the best model. English. So Simon, we are all here. So Simon, we మేము అందరం ఇక్కడ ఉన్నాము. Like we are converting the test, converting each token and selecting the tokens which has the high probability. Like you can see the output here from English and Telugu. Yeah, you can in Telugu you can say అవును. Like English, can I do it to now? నేను చాలా అది కాదు. Like sure. And this was the outputs of that. You can see that for the epoch 2 and epoch, I said that I given totally 5 epochs, and this was the epoch 3. Like in this it was converting into the Hindi, and this was the epoch 4, and this is basic derivative visualization for the validation losses and the visual analysis. Like I am creating a visual graph for the validation losses. I'm plotting the training loss on one side and the validation line on the other side, and adding legend to it. Like you can see that red line passes to the training loss and yellow line passes to validation loss. You can see that. And plotting the global training loss of the attained models. Like I am plotting the again global training step loss. You can skip this part also in your project. I am do it for the my understanding for the visualizations. It was the basic need for the visualization. Like what is going on our project. We are giving the graphs like it was increasing or decreasing validation loss. Is was same, or is there any fluctuating occurring in these training losses? So coming to this part, plotting the global learning rate scheduling for the analysis. Like I am plotting the global learning rate. I mentioned in the above. I will fix the learning rate about this. And this was the embeddings. Loading the best model for the evaluation. I am uses that the translated best model, and loading the static dictionary to the best model, and updating the model with the loaded scale dictionary, and setting the model to the evaluation purpose. And this was the code for that. You can evaluate the best model on the set of random test samples. Like you can see the output for this. You can check out this code and you can understand by reading the comments of the every part. Because when I will explain about this, it will become a long video. You can check out this. I will write. I'll write in the all comments for the each line. You can understand by reading it. You can see the example outputs again. And this was the code. And coming to this part, I explained about this explanation and inference. It was the completely model architecture about this, and this was the model, completely model.
Done.
Yes, sir. And at inferences, I am giving like an input in a tokens format. You can check that it will if we given in a I want to do in English, and you can give a token in Telugu. It will come an output in a Telugu way. Like నేను చేయాలనుకుంటున్నాను. Like in that way, you can convert in English or Telugu or French. You can convert. You can use various types of multilingual models based on your requirements. It was the final product. Yeah.
Thank you, uh, Guru. That was fantastic effort from your side. And what Guru had done is he had designed this multilingual model, sec to sec transformer based model, and this is a case study basically. And he has put comments spread across every part of the code, and that will become very easy for us. Guru, thank you so much, because this is very important for the student community. What I always tell others, that like Guru, you can go on creating the case studies, increase your confidence, and Gen AI, transformers, NLPs, these are the niche things now for to get the jobs. And Guru, also please promise me that in future also you will contribute for the student learning. Okay?
Yes.
How was your experience?
It was pretty good. It was my first video of recording and explaining about the project to the people. It was a pretty good experience. If I done any mistakes, I will let you know, because I will change in a further videos or further explanations. And thanks for this.
Yeah. So what we'll do is, as we go on putting the videos, we'll improve our delivery also, and we'll try to. This was a bigger chunk actually. This was a huge chunk of code. and this was your first video.
Yes.
But your knowledge is phenomenal. Thank you, Guru. We'll stop here now. Give me a minute. Wow.